We've all looked up to the stars and wondered if there is something or someone out there looking back at us. It's a fun idea to think about, but it's also a bit of a frightening dilemma. Either we are alone on an island flying through infinity, or there is alien life out there just waiting to be found, or waiting to find us. And those aliens could come in the form of anything from another humanoid to a Lovecraftian tentacle monster. We don't know what they might be or where they might live, but we are starting to figure it out. It's just in the last 10 years that research into exoplanets has really started to take off, and this field of exploration is getting ready to expand into the next decade and reveal all kinds of secrets of the universe that will probably go well beyond our wildest dreams. So, for today's video, we're talking about the search for Earth-like planets and alien life in this galaxy and beyond. It's pretty crazy stuff, so let's get going. This is The Space Race. The search for an Earth 2.0 is one of the most exciting interstellar projects that we've taken on in the past 20 years. In the past, we could only assume that other stars in the galaxy had planets that orbited around them, but we had no way to know for sure that they existed or what they might look like. Just from observing the other 7 planets in our own cosmic neighborhood, it's obvious that they can come in a wide variety of sizes and compositions. But none of the planets in our solar system are anything like this one. That is to say, they don't hold liquid water or visible signs of life. So we have to take our search further into deep space, and that's where things get interesting. We are looking for planets that sit in the Goldilocks zone in their solar system, meaning they are not too close or too far from the star that they orbit and should have just the right combination of temperature and atmospheric pressure for liquid water to exist without boiling away or freezing solid. We know what the Goldilocks zone in our solar system looks like. Earth is the only planet that is inside it right now, but we also know that it's a variable state as well, because Mars used to be in the Goldilocks zone at some point in the past 4 billion years, but now obviously it isn't. And for the first billion years or so of its life, the Earth was not in the Goldilocks zone, but now it is. And it gets even weirder when you start working in all of the planetary factors that have an effect on the boiling point of water. Because the more pressure that you apply to liquid water, the hotter it can get before it evaporates. Take the bottom of our ocean here on Earth. There are these things called hydrothermal vents, where ocean water seeps down through gaps in the tectonic plates and hits liquid magma under the Earth's crust. The superheated water comes back up and forms the hydrothermal vent. But even at temperatures of 370 degrees Celsius, the water does not boil. The extreme pressure at the bottom of the ocean stops the water from converting into steam. Same deal with a planet. If it has a strong enough force of gravity or a dense enough atmosphere, a planet could maintain a liquid water ocean while still orbiting super close to its sun, and that's actually the case more often than not. Here's something that could blow your mind if you've never seen it before. Our solar system is actually really weird compared to most others in the galaxy. We've all seen the diagram of our solar system. You know, all of the planets are pretty nicely spread out and organized. We've got the small rocky ones on the inside and the big gaseous ones on the outside, and everyone has lots of personal space to float around in these big, wide orbits. But in a normal solar system, the planets tend to float around in orbits that are super close to their stars by comparison. And another weird thing, it's actually much more common for all planets in a solar system to be more or less the same size, like peas in a pod. We can look at the TRAPPIST system. That's one that we know pretty well and can map out pretty accurately. The 7-planet system is so compact that the whole thing can comfortably fit into the space between our own sun and the planet Mercury. The biggest planet in TRAPPIST is the one closest to their sun, and the smallest planet is the furthest out, and the size difference between the largest and smallest would only be a factor of 4 or 5. This is actually really good news for our odds of finding Earth 2.0 because it means that other solar systems can have more dense collections of planets in the Goldilocks zone. A system like TRAPPIST could actually have 2 life-supporting planets or even 3 of them, and they'd all be close enough together that even a civilization that is only as advanced as we are right now could happily travel between them. They could have their own little united federation of planets. Or, equally possible, if they're anything like us, they could have full-on interplanetary wars raging. There's probably all kinds of trippy stuff going on out there that we can't imagine because we ended up all alone in the weirdo solar system. So far, we've identified over 2,600 exoplanets in the Milky Way galaxy, and 16 of them have been identified as being inside the Goldilocks zone. So we still have a very limited sample size of planets to go on here. And even of those 16, we can already tell that most of them couldn't support life as we know it. Some of the Goldilocks planets are so close to their stars that they become tidally locked, meaning that only one side of the planet actually gets exposed to light and the other is permanently dark. Others are closer in composition to Neptune than they are to Earth, with super thick hydrogen-based atmospheres. Of the few potential alternate Earths, there are a couple of really promising candidates, like Kepler 452b. This one is what they call a super Earth, coming in at about 5 times the mass of Earth and about 1.5 times the radius. We're pretty sure this exoplanet is made of rocks and has clouds the same as our own, and probably sits at an average temperature that is just a little warmer than Earth. Kepler 186f is another cool one. This is only about 11% larger than the Earth, and we are pretty sure that it has a stable tilt on its polar axis, the same as the Earth. So it probably has seasons and a stable climate just like our own. So far, this is about the best we can come up with, and any ideas that these planets might support life are really just assumptions at best. But experts are pretty sure that 1 in 5 stars that are similar in size and temperature to our own will support Earth-like planets in their solar systems. So, on the grand scale of the galaxy, the odds are still pretty favorable for alien life, or at least life as we know it. There's the other trippy problem: we can't see what's on these distant planets visually. No telescope will ever have enough resolution to, spy on aliens. We're just looking for the right combination of elements in the atmosphere that would support life on Earth. There could be life in the universe not as we know it. There could be whales that swim in liquid methane oceans. There could be birds that fly through hydrogen clouds. Alien life could be as minimal as something like a tardigrade. Or we could even have H.P. Lovecraft's elder gods out there just floating in space as immortal clouds of tentacles and teeth and shit for all we really know. The reason that we know as much as we do about these exoplanets is thanks to the Kepler Space Telescope. This is named for the 17th century German astronomer Johannes Kepler, who made breakthrough discoveries about the laws of planetary motion. Namely, he figured out that planets are round and move in elliptical orbits around the sun. That's why he's always holding a protractor in every drawing of him. This telescope was launched back in 2009 with what was at the time the biggest mirror ever put into space, and 96 megapixel digital camera, which was a staggering amount of resolution for the time. The mission of the Kepler telescope was to focus on a particular area of the Milky Way and hunt for signs of planets. It was able to do this using something called the transit method, which basically means it just looks at a star over a long period of time and tries to detect any event when the light from the star dims. These limited periods of dimming are a good indication that there is a planet passing by the star. These are minute levels of dimming, but they can actually tell us about the size and orbit of the exoplanets that we find using the method. This is spectacularly hard to detect. The Earth passing by our sun would cause a dimming effect that would only measure in fractions of a percent. It requires extreme sensitivity to detect these changes, and we were able to do it with technology that was invented 15 years ago. The Kepler telescope was decommissioned back in 2018, but it collected so much data in its 9-year mission that we are still trying to analyze it all to this day. I know they are not as exciting as something like the Starship that's so big and powerful and explosive, but space telescopes are pretty damn cool, and we're about to take this deep space observation to the next level later this year. If there's anything that's going to be able to find Earth 2.0 and the aliens that are living there, it's the James Webb Space Telescope. This thing is insane. The James Webb cost $10 billion to develop and is going to be so sensitive to the infrared spectrum of light that it will be able to see backwards in time. No shit. So James Webb is not an ancient astronomer. He was actually a modern-day government official in the United States. Webb was the head of NASA in its formative years from 1961 to 1968 and oversaw everything from the first American in space to the creation and development of the Apollo moon landing program. The first thing you'll notice about the Webb telescope is the humongous, shiny hexagon pattern mirror. It's designed so that it can fold up to fit inside the cargo fairing of an Ariane 5 rocket and then unfold itself into shape out in space. The mirror assembly is sitting on top of an even more gigantic heat shield that is also foldable and measures 20 meters in length. This 5-layer shield will keep the telescope unit permanently in shade from the light of the sun, Earth, and moon. The James Webb is going way out into space to get the best possible view of our galaxy and beyond. It's going to orbit 4 times further from the Earth than the moon, 1.5 million kilometers away from the Earth at something called a Lagrange point. This means that the telescope will stay in line with the Earth as it moves around the sun. This new telescope is 100 times more powerful than the current Hubble Space Telescope. After it launches in December 2021, we can start using the James Webb Telescope to follow up on those Goldilocks planets that were first identified by Kepler. And the power of the new telescope should be enough to start making some definitive conclusions about just what these planets are made of and what they look like. By analyzing the wavelength of light that passes through the atmosphere of an exoplanet, we can actually see all of the different elements that are present in the composition. And of course, we can go well beyond what Kepler saw and start finding new solar systems and new Earth-like planets to investigate. We are going to see all kinds of crazy shit through this thing, and it's going to be so epic. The James Webb sees mostly in the infrared spectrum of light, and it does that for a couple of reasons. Number one, it will be able to see through clouds of space dust really easily. So it could actually see into the core of a planet or a star as it's forming in the middle of a big cloud of debris. And number two, this will allow the telescope to see backwards in time. This is pretty trippy, but basically, if we imagine ourselves in the big cloud of everything that exploded outwards from the Big Bang and formed into galaxies and solar systems, we're kind of in the middle. So there are much older galaxies out there in the universe that are unfathomably distant from us. So far away that the light that was created when the galaxy formed 10 billion years ago is just now reaching us here on Earth. But as light travels that far, it shifts from the visible spectrum over to the infrared spectrum. So we can't see it, and the Hubble telescope can't really see it either. But the new Webb telescope will be able to see the echoes of ancient stars that are long dead. It will literally be capturing a long time ago in a galaxy far, far away, or something like that. Hopefully, I just explained it reasonably well. We'll come back to this in a future video when the telescope launches to talk all about it in depth, so stay tuned and be sure to subscribe. What do you guys think? Are there planets out there in the galaxy that are just like Earth? Are there people out there just like us? Or maybe the universe is too chaotic to repeat anything twice? Let's talk about it in the comment section below. Please don't forget to give this video a thumbs up today. That really means a lot to us, and we appreciate all of your support. We've got 2 more videos on the screen for you to check out. They're pretty awesome. Subscribe to this channel for more videos and ring the notification bell as well. It's a lot of work, I know, but it'll be worth it. Thanks again for watching the video, and I'll see you in the next one.